Number 23 is just a bundle of joy. It is a good question, I will say that, but it has a lot of work. So I'm going to do it. You're going to need quite a bit of space. It's not hard work, or it's not, it is hard work, but it's doable. It's just a lot of work. Which of these systems of linear equations are parallel lines? Now, here's what you need to know that I haven't told you yet. I've told you that parallel lines have the same slope. So that is one way that you could find the answer. You could put all of them in slope-intercept form, that's 10 equations, and find the slope that way. You can do that, but I'm not going to do that. If you have a system of equations of parallel lines, there is no solution. Now remember, a solution to a system is a point. So there is no point that satisfies both equations or that fits both equations because they never touch. Remember, on a graph, the solution is where the systems of equations touch each other. So a parallel line system will not have a common point. And that's the way I'm going to approach this one. I'm looking for the set of these lines that does not have a common point. So let's test them. And remember, we're studying the elimination method, so we're going to use that. So 3x plus 2y is 6. And then we have 2x plus 3y is 5. So I need to cancel an x or a y, and I think I'm going to target the x's. So if I multiply this first series by -2, let's see what I come up with. And I think I'm going to work this way. So I have -6x minus 4y equals -12. And then on the bottom, I need to come up with a +6. So I'm going to use a 3 and then a 3 over here. So I'm going to say 3 times 2 is 6x plus 9y is 15. And so my x terms cancel. My y's become 5y equals 3. Divide both sides by 5. And I'm left with y is 3/5. Okay. So I have a y coordinate. If we can just come up with an x one, we're in business here. So let me pull one of the equations. And I'm going to do it with a different color because I need space. So 3x plus 2y is 6. And we've got 3x plus 2 times 3/5 is 6. So 3x plus 6/5 is 6. I can already tell you this one's not it because it's going to have a solution. Minus the 6/5. Get rid of this. So 3x equals 6 minus 6/5. That's going to be 4 4/5, I believe. But let me do it and see. It is. And then divide both sides by 3. And you're going to get 1 3/5. So this one has a solution. It was a nightmare to find it, but it does. Let me go back up here and put it down there. So we had y was 3/5, and x was 1 3/5. So that tells me that this is not parallel. This system of equations has a solution. So it's not parallel. The lines touch somewhere at that point. Is where they touch. Okay, B. Let me put him, let's see. Let's try this. I'll put B right here, and I'm going to draw lines to separate them because I don't want it all to run together. So here's A. Well, that was not going to work. Have to do it a section at a time, or it confuses the iPad. Okay, here is B. We're looking for the one that does not have a solution. So we have 4x plus 5y is 6. Negative 4x plus 5y is 6. They were nice to me this time because those x terms are already going to cancel. I didn't have to work for that. So I'm left with 10y is 12. Divide both sides by 10. So y is 12/10. Okay, and then let's do x. So I'm going to bring 4x plus 5 times 12/10 equals 6. So 4x plus 60 over 10 is 6. So 4x plus 6 is 6 minus 6. So 4x is 0. Divide by 4. So x is 0. So this one has a solution. 0 and 12/10. So that is not the one we're looking for, unfortunately. Okay, here comes C. We have 3x minus y is 9. Minus 3x plus y is 11. Oh, I have a good feeling about this one because the x's cancel and the y's cancel. So you have nothing on this side. And then on this side, you have 21. Wait a minute. What have I done? I had a 3x minus a 3x. Okay. So those, okay. At no time does 0 equal 21. So this is no solution, which means the lines never touch, which is a definition, a component of parallel. So C is my answer. I'm going to do D and E because I'm supposed to. But if you don't want to watch that, if you feel comfortable with the elimination method, you don't have to watch these. You can stop the video. Okay, here comes D. I'm going to put it right up here so I have plenty of room for E. D is 2x plus 2y is 4. Then 2x minus 2y is 4. And this time I'm ready to cancel y terms, so I'm just going to do that and leave the x's alone. So we're left with 4x is 4. Divide top and bottom by 4. And you're left with x is 1. And then the y component, just pick an equation. It doesn't matter which one. And plug in the x. So 2 plus 2y is 4. Minus 2 minus 2. 2y is 2. So y is also 1. But that's the solution to D. 1, 1. And then finally E, which I do suspect E is going to have a solution because I've already found my no solution one, and that was C. So I have 2x plus 6y is 12. Okay, this one I don't have to do because it's the same equation, right? It's the same equation, so I'm not going to, you can't find a solution if it's the same thing. So that one, not going to worry about it. The answer that has no solution, right here, is C. It's a good question, but it's a lot of work. Okay, I need another sheet of paper. So let me, it is 4 a.m., guys, almost. I just could not sleep, and so I thought I would record math. Okay, here is number 24. And it looks like these two go with a story, so let me not cut off the story. We're going to need to know that story. I believe this might be the end of the, no, I believe there are more problems, aren't there? Or is it, no, this is the end of these. So when we get these, we'll be finished. A group of runners are holding a 5K and 10K event to raise money for the biking trail. The entry fees are $22 for the 5K and $36 for the 10K. The event raised $3,002 from the entry fees, and there were 97 runners. Which system of linear equations would help you determine how many ran each event if X is the number of 5K runners and Y is the number of 10K runners? So let's get this picture in our mind of what's happening. You decide that you want to run in this race to help raise money for a charity, for a biking trail. So you go to sign up, and what's the first question you're going to be asked? They're going to say, do you want to run the 5K or the 10K? So the 5Ks plus the 10Ks equal the total number of runners, which we know to be what? 97. Now they said to let the x be the 5Kers and the y be the 10Kers. That K is tricky because that doesn't mean anything variable-wise. That means kilometer. So the short race, let's think of it that way. The short race plus the long race are your choices. Those are your variables. And that equals the total number of runners. So you could also say that the short racers, X, plus the long racers, Y, equal the money, equal the $3,002. That was the whole point of having the race, was to raise money. So each of the short racers paid $22, and each of the longer racers paid $36. There's the system of equations. Let me bring this one on over. Because if I can get a negative 22 in there, I've got what I need. So I'm going to multiply that negative 22 through to everything. That's the catch. You have to do it to everything. So here's negative 22x minus 22y equals, I have no idea what 97 times 22 is, so let me see. 2134. Okay. Let me try that again. That doesn't look right. It is right. Okay. So let's take out this middle equation. We're not going to need that. So we're left with 22 minus 22. That's a good thing. 36 minus 22 is 14y. And then 3002 minus 2134 is 868 divided by 14. So the long racers were, there were 62 of the long racers. And remember, the solution to a system is a point. And I just started working this. I didn't even read the question, but I know we're going to need to. So let's go ahead and finish it. All right, so plugging into this easier equation of x plus y is 97. And we're claiming that the y's are 62. So the x's will be 35. So there were 35 of the short racers and 62 of the long racers. All right, so which equations are we going to use? I'm liking D as my choice. Number 24 is D. And number 25, how many of each one were there? There were 35 short racers and 62 long racers. So E is the answer for 25. Okay. That brings us to the end of 5.4. It also brings us to the end of Chapter 5. So if you're sick and tired of slope and systems and all that, we're done with it in Chapter 5, but you will use these skills in Chapter 6. So before you start Chapter 6, check with your instructor if you're having any questions about Chapter 5. And I'll see you in the next chapter where we will study functions. Have a good day. Bye-bye.